Kia ora Year 12 and Year 11. This is another video going over the 2014 calculus paper. This one's going to look at question 2F, which was another one where you have to find the equation of the curve. And so here's the question here. I'm pretty sure that this is the question I got all mucked up on in class. So if you're watching this from my class this year, Humour, I still owe you the chocolate. I actually have the chocolate on my desk now, so come in and get it one day during the week. Email me first. Right, so we're given a question here where we're told the tangent to the curve at the point where x equals 3 goes through this point here. And we're given the equation of the curve. We know that it's a parabola, except we don't know the coefficient. So it could be like this, or it could be like this. But what we do know is that we can start to figure out the equation of the tangent to the curve by using the equation of a straight line. So the equation of a straight line is y equals mx plus c. We know that the tangent to the curve at the point x equals 3 goes through this value here. Right, so the tangent to the curve could be like that, could be like that, could be like that. All we know so far is that it goes through there. That means that I can write y equals mx plus 4. Now, we often use this formula to find the equation of a straight line. But if we know the intercept, this one is the best one to use. Okay, so I'm going to work with that. The next thing we say is, well, where am I going to get that m from? Where does this come from? Well, this comes from the derivative of the curve. So we're going to differentiate, and we'll get dy by dx is equal to, let's see, 2px plus 4. And we're interested in what happens at x equals 3. So f dash of x at 3 is going to equal 2p times 3 plus 4, which is 6p plus 4. So we can take this now, we can put this into my equation of the tangent, giving us the equation of the tangent is 6p plus 4 times x plus 4. The next thing to think about is what's the value of that tangent when x is equal to 3. So what we've got here is the equation of the tangent for any value of x, but we're interested in its value at x equals 3. The reason for that is that we've got our parabola, and we've taken the tangent to that parabola at equals 3. So something special happens there. That's where the tangent and the curve just touch each other. So what we're going to use is the value of the tangent being equal to the value of the function at that point. So at x equals 3, y is equal to 6p plus 4 times 3 plus 4. That gives me y is equal to 18p plus 12 plus 4. So y is equal to 18 plus p plus 16 when x equals 3. Now we go back to the curve. We go back to what we know about our parabola up here. So y equals px squared plus 4x, take away 5. And we ask again, what happens when x equals 3? Well, y will equal p times 3 squared, 9, plus 4 3s, plus 5. So y is equal to 9p plus 7, 12 plus 5. That's not a plus, that's a minus. Okay, it would help if I copied the equation down correctly. Sorry about that. Right, so we've got 9p plus 12 minus 5 gives me plus 7. So this is the y value on the curve, and this is the y value of the tangent. But at x equals 3 and nowhere else, those two y values are exactly the same. So we've got 18p plus 16 is equal to 9p plus 7. We have just enough information to solve the problem. So 9 is equal to negative 9p, giving us p is equal to negative 1. Now we can take that. That's the first thing we had to do. The second thing we had to do was find the equation of the tangent to the curve. But we've already done a whole lot of work on that. So if you go back up page, this was the equation of the tangent. right? And we know what P is now. So we're going to substitute in P is equal to -1 in here, if the pen will work, right? So we're substituting in for this now. And we get Y is equal to, so I'll write it out again, 6P plus 4x plus 4. So that equals -6 plus 4x plus 4. So Y is equal to -2x plus 4. Now, don't go away because I've done this in GeoGebra to show you what's going on so that it helps you with hopefully other questions a little bit like this one. Okay, so this is what's happening. Here, the green line is my tangent, right? So that's Y equals -2x plus 4. So you can see that was our starting point, the plus 4. And down here at x equals 3 is where I've got the tangent just touching the parabola. Okay, so that's why this whole question works, is because we know that there's a point in common and we can use that to find the missing value of P. I hope that helped. I'm sorry again about the dodgy screen recorder for this one. Please let me know if the sound quality and stuff is okay. So I'm going to upload this now and come back with some more questions later on.